Hello. All right, last session. So again, thank you for coming back and welcome back. One thing I forgot to do is I encourage you, please, at the end of these sessions to fill out your evaluation forms and submit those, because that really does help us to give you the best possible content and experiences at this conference. So last session today. So we got to talk a lot about the broadcast industry and OTT and play out and media supply chains. We're going to move into content production, and so it's really a really cool use case. You may not have heard of Sundog Media, but you've probably seen Sundog Media. So I'm going to let Con Wilms, who's one of our principal or our primary AWS solutions architects for media and entertainment, and Richard Welsh, who's the CEO of Sundog Media. They're going to talk you through some of the use cases for high performance cinematic production in the cloud. Con?
Thanks. So yeah, my name is Konstantin Wilms. I'm a principal solution architect with AWS, and with me is Richard Welsh. And we're sort of going to split this up today. So we thought maybe we'd split it up as like maybe 60-40 or something to that effect. But at least we're going to look at, from the AWS perspective, production or post-production, if you will. And I'll get a little bit into that as to why we focus specifically on that. But I'm curious to know how many of you are in the post or post-production business or involved with editing in the cloud. Okay. Yeah, so at least to get started, we'll take a macro perspective look at this, so more of like a higher overarching, and then go to the building blocks. So really what we're trying to do here, at least from this perspective, is look at how could we optimize for performance with different building blocks that we have in AWS for post-production pipelines per se. And then I'll hand it over to Rich, who will talk about the Sundog Media Toolkit, some of the things they've been building. I think the important thing to realize is that this is a RHEL system in production. It's been in production for a while, and they're processing a lot of content through it. So that's interesting as well. So, you know, if we look at cinematic production or, you know, cinematic production in the cloud, it could, you know, something like this could take up an entire conference just by itself. And if we looked at development tools, pre-production, storyboarding, etc. So we thought that we'd focus on the post-production piece, and that fits in well with, you know, what Sundog does too, and not so much on the other components. You know, and of course, one of the first things to ask yourself is why utilize AWS for post-production? And these are most of the, you know, I'm sure you're familiar with these, most of the core tenets for using, say, the public cloud or using AWS for these types of workloads. But really, when it comes to post-production, to process content, one of the things that's important is to process content at velocity, and then also different types of content. So you may have more valuable content that needs to get processed at a faster velocity than other content that, you know, maybe it's non-cinema, maybe it's for television release, etc., where there's a longer lead time to actually finish or master or process that content. So some of these are more applicable than others. So increased speed and agility and not having to guess capacity are probably the two core ones there from a post-production perspective. And you've probably seen this as well. So you know, Usman and Michael and, you know, the media supply chain talk, and et cetera. The important thing here is that, you know, across all of these 8 workloads, there's obviously a slot in for post-production here too, usually to the bottom, you know, left there in terms of visual effects, editing, a little bit into archive and supply chain for automation, et cetera. And then acquisition takes a slightly different form in terms of ingest, and then final delivery, which is typically not playout, but delivery of, say, plates or delivery of frames, etc., to third parties. And then the other thing to look at here is, you know, as companies at least play into more of these fields, eventually you start to bring everything into the cloud as well. So it changes the paradigm. So for example, utilizing object store and not having to worry about capacity versus constrained capacity on-prem for doing post. And these are a lot the same as supply chain, et cetera, in terms of decoupling your workloads, looking at microservices, but also looking at things like composable services. So for example, how would we build a production pipeline? We would build our own APIs. Is this something we need to stamp out multiple times? And then obviously performance optimization as well. So when I was talking about the velocity of being able to process this content at scale for these very large frames, et cetera, that's important too. So if we take a look at just from taking that into account, post-production components, we can typically categorize this into 4 areas. So we have some notion of a pipeline or license manager that dispatches our jobs, that then do things like render, transcode, perform metadata operation, color correction, etc. But that maps into a processing farm, which is pinned to storage and which is driven by, for example, edit stations. And if we then take that versus those previous 8 workloads in terms of expanding this, then you get this effect where the more components we bring in, the more we can actually start reusing, say, those APIs or the storage subsystems that we've already put time and effort into. So having said that, I just wanted to go through a simple pipeline, map it to at least what a post pipeline would look like from a very high point of view, high-level point of view, and then map that into at least AWS services and also partner offerings for each one of these phases. And this is you could equate this to your typical post-production pipeline. So we have an ingest phase. Obviously, after ingesting, we're storing, and that content needs to either be stored for processing or delivery. But that could be object store, block-based store, it could be EBS, etc. There's an editing phase, which may be programmatic. It may also be manual. For example, we're using G2 instances running Nuke or Maya or whatever that may be. And then also the processing phase, which is kicked off either manually or programmatically through our editing phase against the backend storage that's been ingested. So if we look at the ingest side, there are a number of services that are pretty self-explanatory here, just in terms of landing the content or landing the source content that we're going to use for post into AWS. So there's some options we have, like S3 transfer acceleration. So say, for example, if we have a number of post houses across the globe that need to submit content to us, we may utilize something like S3 TA for them to upload that content into a centralized bucket. Alternatively, if the model is one of, say, hybrid cloud, then we may have direct connect in place, in which case we could have editors running workstation on-prem with connectivity to burst into cloud for doing the actual post-processing, for example. And there are quite a few other options here. So Snowball for landing content. That is, maybe we don't have the option to do S3 TA. Maybe we don't have the option to do direct connect. So typically, this is your model of dailies or landing that type of content into AWS. And then CloudFront as well, which in this model is more for delivery, if you will. Plus there's Storage Gateway. We see Storage Gateway used a lot for on-prem editing, where you may need to do backups of on-prem resources, config files, mesh files, etc., that don't actually reside in the cloud, and you can utilize that as a way to move that content or back that content up into AWS. And then finally, Elemental in terms of conditioning or preconditioning content. So maybe lowering the bitrate of content, but at a constant quality ratio. That's also an option there. And you can see there are obviously a number of partners that play in this space as well, such as Aspire and Signiant for UDP, high-speed upload. Plus we have a number of other options there too. So if we look at the storage side, here we're looking at are we moving everything all into the cloud? Do we need a hybrid post-production pipeline? And really that then maps to selection of services, of which a lot of these are the same as the previous side in terms of S3, etc. But you also have now options for EFS, block store, Glacier archival, etc. So these are common building blocks, obviously very pertinent to this. And then marketplace is the last thing to talk about here, just in terms of spinning up, say, soft NAS as an NFS server, or Gluster or Luster as an option. There's some hybrid appliances as well, like a Veer. So your use case model there that is actually pretty popular is one where the editors edit on-prem and then utilize a Veer to back it into S3 and then back it back into EC2 instances to actually make use of that data. So on the editing side, and I'll let you get into some detail about this, but it's the same sort of breakdown. EFS is once again pertinent here, just enable in terms of being able to attach either soft or hard or NFS or object-based to whatever we're utilizing to edit content in the cloud. And you can see there are obviously a number of options here like Teradici, Bebop, etc. that provide in some cases full collaborative platforms on top of AWS. And then last but not least, on the processing side, once again, the same type of mix of services of which you probably have noticed that EC2, EFS, EBS, and S3 are pretty much the core tenants, if you will, for building any type of post-production workload on top of AWS. But essentially on the partner side, now we're looking at scheduling such as ThinkBox. We're looking at maybe proxy generation or rendering such as RenderMan. And then we're looking at other packaging or watermarking tools such as Civolution or AutoDCP. So just to dive into each one of these, I've skipped the ingest side simply because we're focusing on the content that's already been landed and the processing requirements around that. But I'll go through the storage, the edit side, and then also processing as well. So this slide is also, this is fairly self-explanatory as well. I'm sure you're all familiar with this. But on the post side or the post-production side, this opens up a interesting avenue in that when I don't have to worry about capacity, I can now start building new types of workloads to handle my post data, since I don't have to worry about where I'm putting those files or how I'm locating them, etc., or partitioning the data. And then if we dive into each one of these, and you can see here that EFS has a little grayed out area under encryption there, and that's simply just because it's not native, but you're still able to encrypt your payload, so you could say symmetrically encrypt your content before you move it back and forth onto EFS. And then there are other options here, and you can sort of look at this from a hot to cold for post-production. So for example, utilizing EBS to store content that's going to get processed. Now, depending on the instance size, you may also opt to use shared memory or RAM disk as well, which gives you extra performance on top of, say, utilizing provisioned IOPS-based EBS volumes. And then the other thing to note here is that, depending on the tools that you're using, so you may be utilizing legacy type tools or pieces of software. Some of those obviously are going to need block or they're going to need NFS type access or capability, and that's where EFS and obviously EBS come into play there. So much like media supply chain, where we take EFS, we land content onto it, and it becomes the hub with all the NFS attached endpoints that are then parallel or in series processing the content. This is much the same type of paradigm for post in the sense. But if you can, then obviously S3, in terms of migrating fully to object store, in many cases for post will give you much more flexibility. So the asset lifecycle here is a lot like the asset lifecycle for supply chain or OTT or any of these other types of media type delivery mechanisms where we're talking about ingesting content such as MES files or source content, storing the frequently accessed content in a certain tier, and then automatically aging it to, say, long-term or deep archive. And this is particularly important for post because there's typically a lot of different, say, camera angles, shots, etc., that need to be stored sometimes in perpetuity until the feature length is done, or the cinematography, etc., is done, or even beyond that in cases remastering or different cuts that need to be made from that. So this asset life cycle that you may associate with something like mezzanine files, etc., is extremely relevant for post-production here too. So I talked a little earlier on the access models, and really what this diagram here is depicting is that for post-production you can look at this, and this is AWS on the one side and then say on-prem or a hybrid type situation on the right-hand side. But you can look at these different types of storage models as either tightly or loosely coupled from the post-production sense. So one of the workflows here with the thicker arrows is pretty much a more tightly coupled workflow in that you have Avere appliances that are sitting on-prem, editors may be working against that. The back-end storage for that is up to S3, and then there's a storage cache which can be utilized by EC2 instances for processing. Similarly, if you were to utilize, say, Lustre against EC2, you'd have the same type of topology as you would with, say, an Avere. But in this sense, we're not actually going back on-prem. We're simply using it as a read-through or write-back caching mechanism against object store for non-object store type application usage. And then finally, we have this notion of loosely coupled, right? So in this mode, we're actually moving content back and forth. So what isn't depicted here is there's some process involved, and this may be part of the pipeline that's actually moving the content off of S3 onto EFS and then kicking off an API to actually run through the pipeline for all the instances that are attached to that EFS volume. So for example, here we could be utilizing Spot instances to do processing. And of course, since this is hybrid, those Spot instances that spin up may have dependencies such as processing algorithms or meshes or any source metadata that may actually reside on-prem as well, on on-prem storage. So there's no real limitation that you have to move everything in, but as you can see from this, you get quite a lot of benefit from having all of the content reside in, say, in a single content type lake, if you will. And then finally, just on the storage side, if we look at what do we do after we've done production or after we've run through actually creating the content, mastering, finishing, whatever that process may be, we once again have a notion here of ingest. So this is where we then have our production archive that could go down into Glacier. Plus, we can also then tie this into supply chain or delivery models. So for example, in this model here, we're actually part of the process is to then move that content to either secondary or tertiary type archival, or this could be a destination that may be another customer, or it may be a master account, or we may be producing source material for a larger post-production workflow that resides on the right-hand side here. And then once again, if we compare these three options here, really the one thing to look at is the latency that we can afford. So this gets back obviously to some of the applications that we may run may have a requirement for NFS. They may only want to talk to block store. They may not be object native at least. But this gives us the option to migrate an entire post workload or pipeline onto AWS and then come back and fix or change the pieces that we want to make, say, everything object-based if that was the direction that we were heading. So on the editing side, this is, if we look at what are the options there, I talked about Bebop, Teradici. This is their 4K client. They have I believe they have a demo in their booth as well of that working. But there are options here for such as workspaces, Bebop, running on top of Teradici. And what you see here is, this is the G2, the new instance that we released with the GPU workspace, running Nuke or Premiere. But the thing I wanted to point out here is that there are two ways to do this. The one is that you can utilize H.264-based compression in order to ship the bits to the client to actually use the UI and so forth. Or you can utilize PC over IP or PCOIP. And you get an advantage to utilizing PCOIP because the heat map that you can see on the right-hand side, and I apologize, the text is a bit small, but H.264 shows you your compression artifacts on the top right. And then you can see the gray artifacts, which these are all text fields, have not actually been compressed. So one of the key things for editors is obviously when they're working in these UIs for extended periods of time, 6-8 hours at a stretch, often it's not really the content that they're looking at, but the quality of the text, the dialogues, etc., that they have to interact with. So not having compression artifacts on that really helps, at least from the eye or visual perspective, if you will. So this is just showing a render utilizing GPU, where Blender is an example here. We're actually just utilizing the K520 to render the scene as a preview instead of doing it CPU-based. But having said that, you can obviously switch between the two there. And just getting back to these cloud-based protocols, obviously these two modes are, one is you compress everything with H.264, and often that's using 420 type color space, so you're losing clarity. You're potentially losing 60–70% of that visual clarity there by utilizing that way of compression, or at least that mechanism of compression. And this is important for, say, 3D editing, such as Maya, etc., where when you're dealing with meshes and vertices, you don't want compression artifacts on the edges of those. So at least 444 type compression that PCOIP uses is a much better, at least, option here, at least for editors in post-production. And then just to finally get into the processing side, these are the same consumption models that we might utilize for your regular type workloads on AWS. But at least on the post side or post-production side, often on-demand is utilized, Spot may be utilized as well. You may be utilizing GPU-based instances, and you may be utilizing reserved instances for things like cluster management, etc. And this really brings us to how do you select between these different instance types for post-production workloads. And you can see there are a couple options here, right? So if we're doing checksums, or if we're doing proxy generation, etc., or if we're extracting metadata, we may be utilizing small burstable instances like a T-series. If we're doing rendering with GPU, obviously we'd be utilizing either a G or a P-series for that. But there are other options here, and I'll get to this shortly as well, where you actually benefit from, say, utilizing obviously as much RAM as you can to load things like textures for processing. Or you may be utilizing some of the C4 type series instances with high capacity 10 gig interfaces on them. And this sort of brings us to two things before I hand it over to Rich. One option here is accelerated computing. So post-production, a lot of these workflows, you can utilize GPU as a way to do compositing or mastering or finishing. And there are advantages to doing this, but at least if you look at GPU versus CPU rendering with post, this is where you can see that it's sort of a trade-off between the two. So on the one side, if you schedule against, say, a multi-GPU instance with software that doesn't really support it, you now have to be setting, am I going to render, say, frame 1 to 25 on my first device, first GPU, and then frame 26 to 50 on the second device? How do I schedule that? How do I map those across GPUs? It leads to increased scheduler complexity, but there's also the advantage of doing that as well, because it may be faster to render on GPU as well. But the underlying thing here is that there are also dependencies for post. So beyond just GPU acceleration, there are many things that are CPU bound as well, such as loading the actual file, parsing, say, the package, if it's a Maya package or Nuke package, etc., loading the actual meshes, maybe doing tessellation, etc., or detessellation. That's all going to be largely CPU bound with no GPU acceleration. And the same goes for a lot of things like compositing and then image export. Those will probably be CPU bound as well. So even though you can utilize GPU here, there are a lot of these additional areas, if you will, in terms of that entire workflow that are largely CPU bound. So with that, I will hand over to Rich.
Thank you. Hi, I'm Rich Welsh. I'm one half of Sundog Media Toolkit. So we're, I was going to say we're a startup, but we've been going for 3 years, so I guess we're, I don't know what you'd call us, survivors or something. We are bootstrapped, and there are literally two of us doing this. We don't have any external coders or anything. So that's just for any of you out there who are like, oh, I want to do something on my own. You can do it for certain. We've been working on feature film stuff for probably about 2 years of those 3. So we stood up some of our services pretty early on and started getting into some real content. So all the stuff I'm going to talk about this afternoon is stuff that is actually out there and is being used on real life content. I am conscious that I'm the only thing now standing between you and the bar, or the copious amounts of bars out there. So I will attempt to keep this lively and quick. So just to give you a sense of what we've got going on in Sundog, it's basically it's a platform. It wasn't intended to be. We just got there a bit by accident. We intended originally to make a playlist mastering tool. Chris, who's my business partner, and I both come from a cinema background, and we'd been working on mastering content for the cinema for about 10 years. And we felt there was a place in the market for a scalable mastering tool, and we started building it. And I think about 2 weeks in, we got totally distracted by someone asking us to do something completely different. And we, like, dogs chasing a car, went after that. So we built a workflow engine, and that actually became the core of the platform that we now have. The workflow engine essentially allows us to scale up pretty much any kind of process. We were aiming this at Hollywood-based kind of content in the first place, so we made a conscious decision not to try and do storage. Essentially, we didn't want to have to handle our customers' data for any longer than necessary. We didn't really want to store it, was the point, because along with that comes a lot of responsibility for security and liability as well. So we built our platform to essentially allow you to connect to cloud storage pretty much wherever it is. So we have multiple protocols available in the platform which you just authenticate your storage to. So your storage could be on-prem, it could be in a a community cloud, somewhere like SohoNet's cloud storage, or it could be an Amazon or another public cloud, and you can connect to wherever your data is and run the workflow, which will then just pull that data in from wherever, and it will actually put it back into a different place if you want. So you can use it as a method of moving that data around, and we've seen that use case with things like visual effects workflows where someone needs to run some processes, but the visual effects guys are actually in another continent usually, so they're able to deliver that data straight to them with the latency of a few frames rather than having to go through a whole file transfer process after they've done the processing. So that's how we architected it, and get a sense of that here, where you can store your data in S3, you can have it locally and move it into S3 via a transfer server, or you can actually just store it locally in cloud object storage, which has been used a little bit. Post-production facilities not at the moment too keen on building object stores when they've already got these huge SANs sitting there that they've got to kind of amortize. But I think that that might be something that we'll see a lot more of, and certainly the vendors for those types of fast post-production storage are now looking a lot at object storage for on-prem. So this is one of our workflows in the UI. So everything we do is all based on a web user interface. You can just log in from anywhere. And the data processing obviously is happening in the cloud, so you're not seeing the data flow to your machine, you're just seeing the UI. We do have proxies for parts of the system that need things like timelines and so on. You can see here these hexagons that are sort of glued together with the arrows. That's actually, I don't know why, but there are hexagons everywhere in the cloud. You've probably noticed this in all cloud marketing, you have to have hexagons. This was not something we realized until after we'd designed the UI, and then we like, oh, everyone's using hexagons. So it's a bit late now. We've kind of rolled with it. Yeah, what you basically do is choose a bunch of processes. We have a tool library, and you can probably see some of the logos down there. DVO's Digital Vision, who make a lot of film restoration tools. We've got some Dolby tools in there. We've got some tools from RealD. So it's become like a bit of a marketplace where you can just plug together these processes and just use them on demand rather than going out and buying hardware, which is what you typically would have had to do in the past for post-production. So I'm going to just quickly talk about what happens within each one of those hexagons. Essentially, each tool is self-contained so that when you plug them together, they can intelligently pass the process on from one to another. Now, it's not completely foolproof. I like to say it's idiot-resistant rather than idiot-proof. If you try and send an audio workflow into a visual workflow tool, it's obviously going to break. But generally speaking, you can pass something from one image process to the next, or from one audio process to the next. And that's because the tools are each sort of self-contained, so they understand what they are, which is the identity. They also understand their dependencies. So do I need to process all these frames before I pass them on, or can I process some and then pass some of those frames onto the next tool? The tool then reports back its process of what it's doing for a progress bar, because people love to watch progress bars. And it has then a data I/O layer, which essentially handles getting that those image frames, for instance, from your storage, wherever that may be, and then obviously passing them on to either the next tool or out to the final destination. Metadata handling, so there's a lot of metadata, particularly with image, that you may or may not want to modify as part of the process. So we have a layer that effectively either passes that on or modifies it as necessary. And then finally the content handling, which essentially translates the image. If it's an image process, for instance, it'll translate the image format into whatever the core wants it to be. So if the processing core needs something like an OpenEXR high dynamic range format, or a DPX film scan frame within the algorithm, then we'll translate it from whatever's coming in, be that a video file or some image frame like a JPEG frame or something, into what the core wants, and then on the way out, we put it back into whatever format it was coming in. There we go. Security, that's like a big deal for Hollywood. You probably know that. If anyone, so I didn't see how many hands went up. How many of you guys work in post-production or in with the Hollywood studios? There's a good few. So the hands that go up will know that you've got to be relatively conscious about security with those guys. So I just wanted to show some of the areas in which you will typically see encryption taking place, because this is something that actually, it's probably one of the biggest hurdles that you have to get over when you're talking about doing post-production in the cloud. People are just totally paranoid that their stuff's going to get stolen, which is fair enough. I mean, no one wants to lose it, but essentially there's a lot of encryption going on. So if you're going to move from on-prem to cloud storage, typically you're probably going to want encrypted storage locally. And actually what's interesting is that as the studios have started to accept the use of cloud for production deliverables and dailies and so on, they've realized that you can encrypt data at rest in basically any storage system. So previously, if you'd got on-prem storage like a SAN or a NAS that had some production data on it, you weren't expected to encrypt that data. And if you're working in real time on it, you probably can't have it encrypted. But once it's going into any kind of nearline storage, the studios are now expecting that to be encrypted, even if it's not cloud storage. So you can, once you've got that encrypted data, you don't necessarily have to decrypt it before you send it. So you can actually send it through a secure transport stream. So you've now got double encryption, which makes it pretty strong, unlikely in the case of a man-in-the-middle attack that anyone could really break that encryption. You definitely have to encrypt it at rest once it's in the cloud. There's no doubt there. It may be double encrypted again, depending on what kind of files they are. So cinema files are already encrypted. You then encrypt them at rest. So now you've got, again, double encrypted in the cloud storage. And the idea really, once you get to the processing stage, is to decrypt at the very latest possible moment. And in some cases, you can really be just decrypting for a few clock cycles, doing a process, and then re-encrypting and putting that data back. So the idea really there is just have the least possible exposure of your data, given that you're dealing with some kind of, big Hollywood movie. You definitely want to make sure it's safe as possible. It's not very responsive, this, is it? Okay, so this is how our scaling engine works. We do use the Amazon scaling tools, but we've also built our own scaling engine on top of that. This is really because of, well, two things. One is that we need to understand the entire workflow and scale up and down with the compute instances we're using based on that workflow, and that requires some slightly more sophisticated analysis than just using sort of simple scaling service. But then also, we need to make sure that we hold those machines alive in case we want to run another process. So we're effectively running something that's akin to our own version of Spot instances within our VPC. So once we've got machines and they're alive, we'll keep them alive. And then if they're not being utilized, we'll reutilize them for other processes. So you build a workflow. That then goes into a machine we call the workflow manager, which basically analyzes the whole workflow using those tool dependencies and tool identities that I talked about before. It decides what it needs to do in terms of how that whole workflow is going to play out, how the processing is going to take place in each block. It then creates one worker, which will be a particular instance. So the process that I'm going to talk about in a minute is, which is called True Image, uses the R3 8x large because we need a lot of RAM. You can really, this is one of the beauties of working in the cloud, and something that's actually quite hard to do in a facility is have really flexible types of machine where you could have RAM intensive, CPU intensive, GPU machines, and just chop and change as you wish for different processes. If you've got to go out and build a really big render farm, you've kind of hung your hat on how that render farm is architected. Whereas you can kind of build render farms at demand in the cloud and vary those sort of elements to balance it out. So we'll choose a worker type that best suits the workflow. We create one, and then that worker knows how many more of itself it will need for the workflow or for the amount of content it's about to process. So it will look at some scaling decisions about what the process is. Can it work on multiple chunks at the same time, that kind of thing. It'll look at the size of the image frames, what's the bit depth, the resolution, what's the total frame count, that kind of thing. And then it basically spawns itself, so it creates lots of versions of itself, which incidentally you have to be a little bit careful of depending what kind of security tools you're running, because this looks like a kind of a botnet cloning itself. So your security tools could flag this as effectively some sort of denial of service attack, except that they're massive machines. So I suppose it's like not really a botnet, more like a Transformers ultra botnet or something. Very scary. But yeah, you can get flagged by security tools. So you have to be aware of that kind of thing if you're going to do this kind of cloned worker situation. So the workers basically then just dole out, the primary worker doles out the jobs to the clones. The clones all report back in, and the workflow manager gives the user a nice progress bar that they can watch ticking away and productively using their time. So the beauty of doing it like this is actually that we can, if we have a problem with either not enough instance types or we have some instances dropping for some reason, we can just jump across to other availability zones. So we typically will, on a big process, run across 3 availability zones in the region, which is really good for resilience. If we lose a machine, typically the user will have no idea that that's happened. That machine dropping will make the primary worker know that those frames are not going to come back from that machine, so it will then give that job to another machine or spin another instance up to go and do that work. So actually it's a really resilient way of doing things, and it's one of the beauties definitely of just using general EC2 resource and CPU processing. And then when it's done, if we don't need to keep those workers alive, and this is all automatic in the background, it will keep them alive as long as it thinks it needs to. Once it's happy it doesn't need any of those machines, it will flush them and then collapse them back down to 0. So again, very cost effective, classic sort of scaling use case. So what I want to talk about is a particular use case that we have in a particular tool. So we have a tool called RealD, that is made by RealD. So you've probably heard of RealD. They're the guys who make the 3D glasses that you've probably worn in the cinema when you've gone to see a movie. They also have a lot of R&D in image processing, and they have a particular tool which is it's a sexy description, isn't it? A multi-mode analysis superpixel reconstruction tool. But essentially what this does is it looks at every single pixel. It looks at all the pixels around that pixel. It looks at the pixel through the color spectrum. It looks at it across frames, so forwards and backwards in time. If it's in 3D, it will actually look between the frames and try and identify that same pixel in the other 3D frame if it's there. And it then uses about 21 different analysis tools to determine what it thinks the pixel should have looked like. And then it will move it slightly towards that value from wherever it is. And then you run it all again. And you do it again and again. And it's pretty intensive. It makes a very fine adjustment. So between one iteration and the next, you probably won't see much. But once you start running lots of iterations, and hopefully these screens are good enough to see it. So what you can see there is quite a lot of noise. That's in the blue channel of the camera. So there's sort of speckling in the background, which shouldn't really be there. Actually, I don't know whether you're going to be able to see that. Hold on, I'm just going to walk out into the audience to make sure I'm not talking about something you can't actually see. There we go. Yeah, so basically what happens with the process, if we can go backwards, is we're taking that noise out of the blue channel in this particular instance. And what you'll see there is that it changes what you can do with the color grade. So the colorist was not able to achieve that with the original shot without creating loads of red channel noise. So it was creating red speckles in the image when he tried to color grade it. But once we'd run the process on it, he could get that color out. The other thing that you get with it, I'll move back onto the stage because it's weird standing here, is you can reconstruct image detail. So on the right-hand side is the original image, and then on the left is the image after it was processed. So it's actually brought texture detail and sharpness back to the image. And this is part of the super resolution kind of process. It's commonly used actually in astronomy where they'll take lots of pictures of the same patch of sky over lots of nights, and then they'll use computer analysis to then rebuild a much higher resolution image of that part of the sky. It can be used for lazy VFX work. I'm not saying VFX artists are lazy, by the way, but sometimes they might paint something in and it's a little bit of a slightly rough job. So what you see there in that circled area is something where there's been a bit of the image is missing and they've just kind of smeared it across. And then you can see after True Image is run, it's basically cleaned that up, as well as getting rid of the noise and improving the detail in the face there, so you can see what that's doing. I don't know if I have got time for this. So I'm going to show you a couple of other things to do with vector scopes, because they're always exciting, aren't they? Especially when you really want to go and get a beer. So this is a shot from The Hobbit. This process was used on The Hobbit. It was not done in Sundog, because The Hobbit predates Sundog by quite a long time. But it was, in terms of the actual process, it was they cut their teeth on this movie. So I thought I'd show this as a good example of what's going on. If you take a source and then you blur it, if you're trying to reduce noise in an image, you can actually just blur the image, and that is a good way to get rid of like speckly noise, but obviously it makes the whole image look soft. But what you see happening on the vector scope there is that the waveform effectively is tightened up. So what that's showing you is there's more kind of coherence of color in the image. So it's actually sharpened up the color. If you were a colorist, what you would be seeing there is that you've got a more coherent image. When it's fuzzy like that, you've kind of got lots of noise, which is effectively spreading out the color into a wider range, and the noise is the stuff you don't want. But you don't want to blur the image, so it's good for color, but it's not good for the picture quality. If you sharpen the image, what you end up doing is actually increasing that noise spread. So what you see on the vector scope there is that the color data is now spread even further out, so you've got less coherence in the color. That's not good from a creative point of view. And you probably guessed that if you run this true image process, what you do is you get a tightening of the color coherence, but you also get better image detail. So this is why people are quite keen to use it. It's mostly been used on high-end movies, but we have done this on some indie movies. So, and again, this is kind of one of the benefits of the cloud. If you want to just use something once and then never touch it again, you're not having to go out and buy really expensive equipment. You can literally just run that process on a problem piece of material and effectively have access to something that otherwise would be the preserve of only really big budget movies or TV shows. So one of the benefits of all that stuff I was showing on the vector scopes is that it actually improves compression efficiency. So those of you who are into compression will understand the terms PSNR and SSIM. So that's the signal to noise ratio, which is essentially the difference between the original image and the compressed image. And the structural similarity, which is more like the human visual system perceived difference. So have I retained the structure of the image effectively? Normally, if you blur an image, then you get better PSNR, because effectively you've got rid of the noise, so that's great. But then the structure of the image has gone away, so that's not good. If you sharpen the image, you get high structural similarity because all the objects are now got nice sharp edges, but you've got a poor PSNR, so you've got more noise. And again, if you run this true image process effectively, you end up coming out with a high PSNR and a high structural similarity, and that will allow you to have better compression, typically in the order of about 20 to 30%. So this was a problem that was that cropped up on Ang Lee's new movie, Billy Lynn's Long Half-Time Walk. The reason being they shot this in a slightly different format to usual. It was 120 frames per second, which is to start with is a problem. And that is a problem because the camera is now exposing effectively 10 times faster, sorry, not 10 times, 5 times faster than it would have been. So you've got 1/5 the amount of light coming in, so the noise level goes up in the picture. It was in 3D, so they had 2 cameras running at 120, so there was 240 frames. They did it in 4K, real 4K, cinema 4K, not UHD, which is fake 4K. That's just a cinema thing. And it was in high dynamic range, so 16-bit images. The result of that is that the uncompressed data rate is 40 times what you would normally get on a movie shoot. So where a movie normally, the uncompressed data for a 2-hour movie would be in the order of a few terabytes. In this case, it was into the hundreds of terabytes because it was 4K and the high frame rate. So we were dealing with a lot of data. This is important because I think a lot of people's perception about doing post-production in the cloud is that you can't really work with uncompressed data in the cloud. It's not feasible. I mean, how do you even get it there is usually people's concern. But actually, you can do that, and we did on this movie. So you've got 2 really kind of viable options, I would say. You either use direct connect and a high bandwidth connection, or you can snowball it. And snowball is actually a really cost-effective way of moving the data in. If you don't have to keep moving the data in and out piecemeal, then that's probably a better option to move a large amount of data in, very cost-effective. But otherwise, typically big post houses will have a 10 gigabit connection available. So something like direct connect is quite feasible for a post house to do these days. And then you can work on uncompressed data. Just to show you what was going on with that, these are actually the same color curve applied to the image, and the one on the left is before the processing and the one on the right is afterwards. We sometimes say it's a bit like having frosted glass. And you can actually see all the color noise there, which is the speckling. And then once that noise has been taken out through the process, obviously you get the clarity of the image back. There is actually the same color tone curve on those 2 images. So although the color looks different, it's not. It's just the amount of noise that's actually effectively in front of the image. So that's what we were doing on that movie. So we had to run it a lot of times. So we ran 10 iterations of the process. The reason I wanted to show that was that as the sort of the final part of this, it produces quite a lot of data points. So each pixel is referencing, as I mentioned before, all the pixels around it in space, through the color spectrum, and also through time and in 3D across the images. The net result is that by the time you've run 10 iterations of the process, you've created 56.1 trillion data points per picture frame, which is a lot. So really, there is no way you can run this in local hardware. I mean, you could run it on your laptop, but you wouldn't get the movie back for like 2,000 years. So it's not really feasible to do it in any place other than the cloud. We were running tens of thousands of CPU cores on this process, but that meant that we could do the job in a couple of days, which is perfectly adequate in a feature film post-production pipeline. I think the interesting thing from my point of view is that this process was sitting in an R&D department. It has spectacular results, but there was no way to productize it. And now, because of what you can do in the cloud and because of the scale of Amazon's public cloud, essentially we can bring products like this to the market, and not just for big feature films, actually, just for any filmmaker. There is obviously a cost involved in doing like a big thing like the 120 frames per second stuff. But for the average filmmaker, it's actually feasible and cost effective to run processes like this on just normal content in a normal post-production budget. So in conclusion, the challenge is really the scaling to the 120 frame 3D 4K was the biggest challenge on this particular job. But again, this is something that once you've built that scaling engine, if you're in a big enough data center, you can do it. So we've been really happy to be able to do this stuff in the different AWS data centers we use. For this particular one, we were in Virginia. But we have also run it in Oregon and Ireland, so we've moved it around the world for different films. I think the other big challenge is breaking the traditional workflow, i.e., traditional thinking. People aren't readily going to start breaking their feature film production workflow just to try some experimental process out. So you have to find people who are prepared to kind of take a punt on doing it. But we're finding more and more that's the case, that people want to use different tools like this, and they are becoming a lot more accepting of the cloud. But that is with the caveat that you have to stay safe. So really thinking about security a lot is, that's important, especially when you get to that end of the kind of content spectrum. We've had some good customer feedback. The post-production facilities themselves feel that it's changing how they're able to work, because they're effectively able to access high-end processes without making that CapEx investment. So I think there's a big opportunity here for the industry as a whole to start deploying a lot of these processes in the cloud in a way that will allow more people to use them. I think there's just opportunity to get more usage out of these processes and not have to stick with this kind of model of buying boxes that you then have to get your money back on over a few years. And then the creatives, what's been quite nice for us is that if you're working in sort of film and television, at the end of the day, you're trying to keep the creatives happy. And we always talk about preserving artistic intent and delivering the vision of the director or the creatives involved in the process. But rarely is the technology actually sort of in the forefront of the creative's mind. In fact, it really ought to be invisible to them. But when you can actually deliver something new to the creatives that they love and they want to use, and that's really kind of a gratifying thing for engineers, because it makes it worthwhile essentially for us to do it. So yeah, we've had good feedback from directors that they actually feel it changed. Having access to these tools that they couldn't use before has changed the way they work. With that, I think we've got 3 minutes of extra drinking time that I can give back to the audience, unless anyone has any questions. Oh, there's a question. Are they supposed to have a mic?
I guess
questions?
So, yeah.
Oh, there's mics there.
Hi. So you can answer no comment to this, but indie filmmaker has an hour-and-a-half film they've shot, using somewhat pro gear. They want to run it through True Image. Ballpark cost?
Come and talk to me afterwards.
No comment.
Well, I mean, list price for a 1.5 hour movie?
Yeah.
Probably about 15,000, but it's negotiable.
Thank you.
Any other questions? Pricing questions? Those are normally awkward ones, but stuff.
All right. Hey, thank you, everyone. I really hope you enjoyed the pre-day.
Thank you.
Thanks for coming. We'll see you in the rest of the show.
All right.